So why is a data lake assistant an important problem to solve? So some of the common questions I get asked is how do I get this piece of information? Understand. So you need an understanding of the data catalog. When was this data set last updated? About data quality. How is this particular column derived? It's about the question about data lineage. When I use this data set, can I make this assumption? It's a question about governance, which you need a good knowledge about the process. So why do you need to use agents? So one thing is managing complexity. The other thing is like fragmented tooling which currently exists in the data mix. Why is an LLM agent-based solution is uniquely suited to this problem? So one thing is it allows you to do natural language coding of complex metadata. Second thing is it allows you to an LLM can reason across structured and unstructured metadata, and it can also explain derivation and lineage in terms. It can provide judgment and guidance on assumptions if it can have access to the design documents and potentially the source code. So ultimately, it's about reducing the operation overhead and democratizing this data access. And in doing so, by building an agentic solution, we make it future-proof, adaptive, and incrementally improvable. Let's look at the architecture of the data lake assistant. So we have the orchestrator, which is the main agent, and it has sub-agents, retrieval, lineage, reason, and quality. These agents help orchestrator to come up with the answers to the questions. Welcome to the data lake assistant demo. So as you can see, we have a bunch of tables sitting in a blue database. This particular table is called actor, and it is a demo table with the actor ID, first name and the last name. It was created on November 26th at 12:09, and the location is S3 location. And now we go to the process which this date tables were used to be created. So it was created using a crawler, and as you can see shortly, the crawl run summary shows you that it was the actor table and a whole lot of other tables were created. So now we are going to run this. How did this Aquila actor table get created? Question. So we are just running through the function of Python. And as you can see, the user prompt is how did the Aquila actor table was created. And, as you can see in the logs presented here, there are calls to localhost 3000. This is where the AWS data processing MCP server is hosted. So if you look at the response from the agent, the agent says the actor table is an external table that gives the location, the column names, etc. That's it. Thank you for listening.